Now we're going to be moving to Roundtable A on harnessing the potential of fusion energy. Each roundtable is divided in two parts. We have a keynote speaker, and then we have a panel with a moderator for discussion. So for Roundtable A, I would like to ask Marc Lachaise, F4E Director, for the keynote speech.
Is it okay? Yes. I'm back again. Don't worry, you won't see me anymore after this. It's not. But we thought it was useful to open this first roundtable with a journey. A journey taking us back to the past, to what we've done, what we've achieved as Europe, but also looking at the future. We all know, and I think everybody here is able to advocate the potential of fusion energy. So I won't come back on that. If you have any other ideas to promote what we try to achieve, we all know that we won't face the same situation in terms of fuel that we have on other energies. We know that this is contributing to decarbonization because it's CO2-free. We know, and we can expand quite easily, that it's safer by the nature of the reaction compared to fission. So I think this is our main selling point. And it's amazing to hear now people not from the sector explaining that. Bankers listening to a capital venture. These are the advantages of fusion. So moving from the labs and the scientific or engineers we are to a field which is more into finance. But this is not the objective. I think I would like us to have a look together at what's been achieved so far. This is a sample of a bit the story, the European story of fusion, of course with some selections. But here you see the different devices by the size of the plasma they will welcome and with a date of birth, and unfortunately for one of them is that of death, which is JET. We can start the story a long time ago, of course, but I think here I would like to mention ESADE, which was the pioneer in terms of plasma confinement and help us to understand a lot on this important thing for fusion. Of course, we can mention WEST. WEST is showing the capacity to operate with ITER-grade tungsten components. And WEST, as mentioned by MEP Güttler, had a record-breaking 20 minutes a few months ago. A bit bigger, DTT, still a project for the future, but it will also be part of the big family. And then we move to a slightly different type, which is Stellarator, Wendelstein 7. For those who hadn't had the chance to see the device, I had the chance to have a tour with Sibylle Güttler and a few colleagues there. It's quite impressive, and you know also the achievement they had just a few days ago. Something we should not forget, and I know it's close to the heart of some of you here, is JET. JET is the most fantastic achievement we had as Europeans in terms of fusion. Everybody who's worked on JET has left something there, but has kept something. And it's quite amazing to see this JET family and community, and when you saw that this has been operating for nearly 40 years, we understand why. So JET was a pioneer as well in our story. If we move closer to today, GT60. I mean, GT60 is the biggest tokamak in operation today, and it's half European. So it shows as well our ability to work with partners. Working with Japanese is not always easy, but it's delivering benefits. And today we can proudly say that we have 50 and we've made 50%. We will operate and learn from this tokamak in Naka in Japan. And of course, ITER, the flagships here, where we have a participation, which is by far the biggest in terms of companies involved, in terms of investment. The share of Europe, you know, is about 40 to 45%. So let's have a look to JET, just some memories and understanding. Now we go inside. It's a picture I saw in some offices in F4E. You can appreciate the cladding, which has to support, of course, all the constraints we know. You can see also something which is interesting for us, for ITER, for the future, is the remote handling device on the right-hand side. And we can have a look to what was the record from JET. So they are real pictures. I'm sure a lot of people are able to comment that this was on the 3rd of October 2023, a DT reaction with 69 megajoule, which is a record in itself. Coming back to West and Wendelstein 7X, we have here the figures I was mentioning before. So February 2025 for West. West is in Cadarache, very close to ITER. 22nd minutes, which is a world record in terms of duration. A fantastic story as well to show that the duration, I mean, I'm quite new to the sector, I must admit, but since I'm paying attention to fusion, we see a moves in terms of second, 2 minutes. W7X is also a very good performance with what we call the triple product, which is the highest ever achieved on the 22nd of May 2025, 4:43 seconds. But the triple product is really what's striking in this day of the 22nd of May. GT60SA, have a look to what is the biggest today with supraconductors. This is the control room, and you might remember, for some of you, the first plasma, which took place with the presence of Commissioner Kadri Simpson in December 2023. So we still have, of course, a lot to learn, and we are working jointly with Eurofusion as well to make sure that Europe is part of the story of operation and learning with all the knowledge in the labs and some of you in the room. Let's move now to ITER. ITER is not so far, if you check, but the road is a bit long and the train is a bit slow, but it's less than 40 kilometers from here. And this is a view of ITER today. So Pietro could not be with us, but I have the full power to represent ITER and proudly share this. This is a construction site. So you might recognize, for some of you which are familiar, you see the tokamak building, which is more than 60 meter height. And the progress today in terms of buildings, construction is nearly there. We still have one last building to do, but the control room is ready. And the components are coming there. I was mentioning before the vacuum vessel, for instance, for Europe. ITER, as I was saying briefly before, is unique. It's the only place where we'll demonstrate that all the assumptions and challenges from the engineering standpoint and technological standpoint will be proven. And I think we should not forget that. It is the only place where we can show burning plasma. So really the flagship of our project, our European project with other members. This is something that happened very recently to show consistently with what Massimo Garriva was saying. Things are going well, are going on track. This is a module which is going down on the pit. It's 1,300 tons, so we need 2 cranes of 750 kilos to move this slowly, and this is not real speed, slowly to the pit. Compared to where we were a few years ago, this is a major achievement. And I think it's important to realize that and to share that as a boost of positive energy also for what Europe is achieving there. Here we have a few pictures. I saw the teams from ASG, and we have some magnets here. You see people in the middle. We are dealing with Guinness Book. I mean, I'm sure as scientists you don't really care Guinness Book, but when I go to a library with my son showing that the reason why I'm coming back late and traveling alone is in the Guinness Book, it gives an impression that I do something of interest for him. And that's the biggest magnet on Earth, by far, even compared to the CERN ones. We have also some pumps, cryo pumps, and many other stories. And I think each of those successes must be celebrated as such. I try to go as much as possible and engage with supply chain, go to the factories, but really this is what's happening today for ITER. It's happening, as it was said by the Member of Parliament and Deputy Director General with European money. This is the investment we've been making through Fusion for Energy as a contract machine, as Massimo was saying. Substantial amounts, up to 7 billion today. You see the slight drop in 2024. This will change in 2025 and in the next year. But all those amounts are going to the supply chain to create jobs, innovation, and promote fusion. This is an example of the knowledge we've been building in the interest of Europe and the member states, an extensive database about fusion supply chain. We have more than 2,500, depends how you count, because you know in the industry you have tier 1, tier 2, tier 3, so it's probably more than that. With 200 technologies mapped in 23 EU countries. And I had the chance to meet a new company from Slovakia, which is in the room. We try to make sure, of course, with public procurement that we extend as much as possible the footprint across Europe. So this is one of the legacy from ITER, from the projects, and we keep working on this. Let's be clear, it's a fragile asset. I mean, some of the contracts are finished, components are delivered, and there is a challenge for industry to find the next market. We know, and we will update this year some of those figures. We're creating jobs, we're creating new technologies, and we clearly foster European competitiveness. I think in the trajectory of the European history for fusion, we should not forget this. And again, this will be updated this year with a new study. I want also to mention the people, because I discovered a vibrant community, people working together, and we try to estimate here, and I'm happy to take the challenge if we miss something, but I asked to the team, how many people are working in fusion in Europe? So that's the result of our estimation. Of course, we can find the people working in R&D, in laboratories, through the Eurofusion survey. We can add the people, easy to count, in F4E, in ITER. But then we have the supply chain, and it's thousands of people. So I think at least we can say we have probably 10,000 people working today in Europe for fusion. And I think you're part of those 10,000, but you're a bit different because you can make a difference as well as leader of the industry. But really we are supporting quite a big number of people across Europe working for fusion. This is what I was mentioning before. You can make a picture and have access to the full report from the Fusion for Energy Observatory. This is the figure, so this is really new. We made it with a few colleagues and a few trainees as well, and a bit of AI, because I was not comfortable, Mr. Goetler, to see in the parliament people quoting US dollars. I mean, I've been in meetings with saying the investment in US dollars from the FIA. I think here we wish to propose a reliable source of European information. So here, this is the picture of the private investment in fusion. You see the increase from 1.5 a few years ago to 10 billion. And I think it's nearly above 10 billion because I saw that one of the startup, Proxima, managed to have a bit more money yesterday. So congratulations. But you see here clearly the sharp increase, and you see where the money is landing. It's not landing here, by far. It's landing in the US, landing in China. So here, I just put this on the table. There is a round table to discuss this, but I wanted to share the fact and have a look to the report. The report is also showing, interestingly, that Europe is investing in the US. So European money is not only not going to Europe, but is going to the US. So here a few figures as well. There is a specific round table. In a nutshell, and this is consistent with the figures given by Massimo Garliva before, this is the total investment flows, and it's quite obvious when you think about it, but the report is showing that we've been investing massively in Europe through public money on the supply chain. Not as much on the startup, but on the supply chain. So the asset we have today is the supply chain. We need to help, of course, private sector and startups to get as much funding as possible, but we need to leverage as well on what we've been collectively creating. So this is an interesting picture as well. Maybe as a form of conclusion, I think this is really consistent with the vision of Fusion for Energy. We've been working with the governing board, and I think it makes also an echo with what I hear from some of you. Fusion for Energy, we're here to deliver, with your help, of course, and it's clearly the first priority. We're here also, and I do believe that our job is to make sure that across Europe we can attract talent. We can build career path. We can make sure that some of the colleagues who were working for us are not going elsewhere because we have things to propose. But this is a challenge. And the third one, it's clearly to create a competitive European supply chain. So it was for me a way to introduce the roundtable. You won't see me before the end. I will sit quietly with Massimo and listen. I've seen a bit the quality of the panels, the intensity of the work from the teams, and I think it's time now we start with the first roundtable. So to start for the first roundtable, I have the pleasure to welcome someone I knew a few years ago, well known in Barcelona and also abroad. He's a professor at ESADE Business School. ESADE is one of the top schools. ESADE now is in top 10 from the very famous Financial Times ranking. So it's good to have someone who is not from Fusion, but knows business, who knows people, and will ask the right questions. So I have the pleasure to welcome on stage Jonathan Wareham from ESADE.
Thank you. All right. How do we proceed? We just...
You can call the speakers, or
okay.
I call them as you wish.
Okay. Will they need microphones? Or?
Yes, the microphone will come, I think. No? I think you can call them
okay.
with the microphone.
All right. Very, very, very good. All right. Thank you very much. I was, in fact, had the pleasure of having Marc in one of my classes many, many years ago. And when I learned he had assumed this very important position, I was, of course, very, very proud. Not only because it's very prestigious, but also because Fusion for Energy is the potential to make such a huge impact on so many things, not only the business end, but socially and environmentally and so forth. So we're very, very proud of you, Marc. What's a business guy doing here at a Fusion, conference? Does he even know the difference between fission and fusion? I think I do. More importantly, the past 10 years of my career, I've been studying big science research infrastructures, the IRA Forum, entities, CERN, EMBL, SREF, XFEL, etc., understanding how the basic work of fundamental science translates into the world of business, their technologies. And typically, the way, a business professor or an economist would look at a lot of these issues is through economic multipliers, a lot of the data that Marc just presented, jobs, spin-offs, patents, perhaps publications. And that's sort of looking at the past, which is what we do most often. But today we have the opportunity to have a more forward-looking conversation about how to build something, something that's more effective at the level of basic research, at the level of engineering, at the level of building something that functions, at the level of societal impact, ecosystem, the Fusion ecosystem. So it should be a much more normative conversation of what we can do better to accelerate. We have a very qualified roundtable panel for you today. Two of the members are not here. I don't think Jérôme is here either. But we have, I'll just introduce them. The idea here is that we are going to try and look at different stakeholders in the Fusion ecosystem and understand their different perspectives, bring out some tensions, make them salient, and understand how to navigate those tensions a little bit more effectively, okay? So Jérôme is not with us, but then we have Carlos Alejaldre. Carlos, please come on up. Oh, there he is, Jérôme, okay. You weren't in your seat. All right, please come on up. Jérôme is from CEA, the French Atomic and Alternative Energy Commission. And he is very qualified to describe what's going on in the world of fundamental research in fusion. Then we have Carlos Alejaldre. Carlos, many of you know, he's been in the world of fusion for many, many decades. So, although his youth defies that statement, He can give us the whole political perspective, geopolitical perspective on what's going on in this space. Amaya Zora Garmendia was supposed to be here. She's from IRAM. They're a large engineering company based out of Spain that builds a lot of these things. Unfortunately, her plane was delayed today or canceled. We are lucky to have Lucio Milanese, and he is from Proxima Fusion in Germany, anywhere you'd like. He's representing the world of startups, the entrepreneurial aspect. So I'm a little bit new to this space, so they have a beautiful website, by the way, just absolutely stunning. But then, of course, I went in and I said, are they really the leading startup in fusion energy in Europe? So I went into ChatGPT and I asked, who is the leading startup in fusion in Europe? And it is in fact true because ChatGPT says so. So he's going to tell us about his trials and his successes. And finally, we have Francesca Ferrazza. She's the head of magnetic fusion initiatives from ENI Italy. ENI Italy is a large energy company, and they have been very forward-looking in terms of investing in fusion, unusually so. So she can offer her perspectives of what excites them about fusion and how we can get other energy companies engaged in the space. And then we have Marco Nassi, CEO of ASG Superconductors. Some of these large magnets that were being shown, his company built. He's built them all for CERN, for GSI, for many of the tokamak reactors and so forth. And so he'll tell us what it's like being a vendor in the fusion space and some of the things that we can do to improve that. So, sitting down. So I have a list of questions. And let's start with Jérôme. What's going on in the world of fundamental research? What are the biggest challenges that need to be solved if we're going to bring more of this to fruition quicker?
Well, there are a number of them, as you have mentioned already. But I guess for the fundamental research, I would say that we have at least provided already one solution, which is ITER in terms of size. So today, the main challenge for research is to study burning plasma, because the purpose of ITER is to study plasma which are heated by alpha particles, which are produced by fusion reaction. This has been seen a little bit in jets, but of course at low level. So now the question and the big issue is how the behavior of the plasma under the heating of alpha particle. So that remains the main challenges. I think the other one is one we are tackling, I think, at CA in particular, is the interaction of the plasma with the wall. Because in all the tokamak today on the facility, also in accelerators, we are doing plasma for a very short time. I mean, maybe if we go 22 minutes, it's still not 24-hour days during years. So we are very far from the fluence or the plasma flux on the material, on the plasma-facing component. So I think this is another challenge, which is on the fundamental research part of plasma physics.
Would you venture any, I know this is the question you hear all the time, but what's your outlook on solving some of these problems?
I hope we will have answers with ITER, sure. Before we are trying to make modeling or simulation, and we have lots of various solutions or things. But yes, I think ITER will give us all the results we need, also maybe for plasma wall interaction also. So that's why it's really a key device. But so far, I think we can also have answers in the coming years, for instance, in several facilities which are exploring long pulse and steady state operation during days.
Okay. Carlos, I guess the geopolitical consequences of energy markets are all sort of quite clear to us, been made so in the past, if they weren't, they've been made so in the past 4 or 5 years. What do you think the role of fusion research is in geopolitics, or how do you think geopolitics has influenced fusion research?
Thank you very much for the invitation to be here. It's a pleasure to be again with so many people I worked in the past. As it was said, is a long past. I mean, okay, this is actually something quite interesting about fusion, in my view. Well, from a global geopolitical perspective, I think we have to put the work on fusion, on trying to produce electricity using these nuclear processes, in particular, I mean fusion, on this big on energy. We have to talk about energy consumption. When you look in something, some charts coming from the United Nations where they plot the Human Development Index with the consumption in electricity, it's a quite interesting chart that I invite everybody to look in the you can see that there is one in the Wikipedia and also in the United Nations Human Development Index. It's a kind of when you put in a scale, in a plot of the what is the level of the Human Development Index and the level on the x-axis, you put the amount of electricity that per capita in the different countries, you see that there is a very sharp growing up to 4,000 kilowatt hours per person, and then kind of stabilize. And then from these 4,000, you have the countries, mostly Occidental, I mean, high developed countries. You have or most of the European countries. Then a little bit further away, you see the US, you see Canada, meaning that it doesn't matter how much you increase the kilowatt hour per capita, but you more or less get the same standard of living. But to get to this 4,000, the problem is that we have what? The whole Asia, we have the whole Africa, we have Brazil, we have, I mean, what can we do geopolitically in my view? Two things. Either we give them electricity to these countries, or we make a revolution and we put dictatorships and we say, well, you are going to be slaves. Because this is really, in my view, the only two possibilities. And here is where fusion comes as a big promise that we can deliver energy all over the planet, if we are able, of course, to solve the issues related to our technology. And this, in my view, it has been very clearly understood, and ITER is the very good proof that it has been understood by everybody. I mean, who is in ITER? 80% of the gross national product of the world. They are represented in ITER. How started ITER? You may recall, I mean, this is one of the things about being old. You may not remember that the first meeting between Gorbachev and Ronald Reagan, 83. We are thinking, it was in the year 85, sorry, I believe. And what happened? I was working in the US at that time, and I had I saw the New York Times. I used to have the New York Times at home, so I took the first page of the New York Times that said, big agreement in the Geneva meeting between Reagan and Gorbachev. I still have it, and I use it in my talks quite often. When you read actually what they agree, they didn't agree on anything. They said that they were going to agree, but really they didn't agree on anything except in one thing. They say, let's do together fusion. That was the starting point of ITER and how we got. So it has been always understood the power that we have, that the energy, that this possible energy has in order to solve issues which are geopolitically for the benefit of the whole humankind. So this power, I think, still is our duty to deliver to the humanity, so we can, I would say, solve this issue.
Marc has shown some graphs where investment in uptake in fusion research has expanded substantially in recent years. Is there, which most of us, I think, would consider that to be a positive development. Do you see any political changes on the horizon that could change that? He had talked about a pendulum of pro or contra nuclear research in general for various reasons. What's your reading of the political environment today and where it might be 4 or 5 years from now?
Well, I think right now we are in a very interesting point, in my view. If you recall, in 2022, we had two big points, two big success in the fusion community. One was in the US, when the inertial confinement fusion, the NIF experiment in Livermore, delivered for the very first time more energy that you were giving to some target, with laser in this case. They deliver the fusion reactor, fusion was produced, and the reaction produced in the order of 2 times more energy than it was put. Actually, only a few days ago it was published that they obtain 4 times the 2 megajoules that they put into the target. That was the very first time that, let's say, what we call Q greater than 1 was obtained, more energy than it was put into the system. The second one was more or less at the same time, and it was mentioned by Marc, JET. JET in 2022 also obtained globally quite a huge amount of energy, thermal energy, coming out of these fusion processes. Still in JET, we did not produce more fusion energy than it was put in order to produce the fusion. But nevertheless, it was produced. So when you combine these two items with the situation, as it was also mentioned by Massimo, that the slope in ITER changed from a, let's say, relatively negative to a positive one, that we see, and we listen also to our parliamentarian, how impressed he was with the visit to ITER. When you see these 3 connections, plus, I think the idea that suddenly there is a public interest, private interest all over the world on fusion, and money starts to flow. I think, to me, that this is an indication that we are in a totally different world right now for fusion, that really everybody believes, or we all believe, that fusion is possible. Until now, it was kind of a research that we were doing in the labs and so on. But now people believe, now we have again to deliver. But this, in my view, changes totally the panorama, how this energy should be seen.
Jérôme, would you echo that sentiment?
Maybe yes, from maybe the press or the global public, it seems to be a very serious progress, and it is. But as I say, it is more in the physics part or fundamental research, as you say, where there being a breakthrough. But the problem is now we have to face with the technological challenge to go to the power plant, and here we are starting really we are very at beginning of this phase, and the difficulty is because to progress on this phase, we need large infrastructures. You have seen ITER, but of course, if we want to progress for the technology, we will need large infrastructure, and that is very difficult to find the money to build them, and in particular in parallel of ITER. So this is, I think, the main point now. We can still progress on physics or on gain or these kind of things, but the step with technology is still very large.
Okay. Lucio, you come to this from I don't want to say the opposite, but from a different perspective. You're coming as a privately funded startup. You're working with a different technology. Tell us a little bit about where you are in Proxima Fusion to begin with, and then what you see some of your greatest challenges are, in the here and now, not only as a startup, but also with respect to what can be done at the level of the European Commission to make your life a little bit better.
Yeah, absolutely. So we are about 2 years old. We were born in April of 2023 as a spin-out of the Max Planck Institute for Plasma Physics. We're working on the stellarator technology, which is, I would say, more or less a complementary approach to tokamaks. It's still magnetic confinement. 80–90% of the fundamental technology is similar to tokamaks and ITER. There are some twists, no pun intended, in the shape of the stellarator. But other than that, it's not really a super orthogonal technology, but is a technology that is important to explore because it offers some advantages vis-a-vis tokamaks, on which I actually trained, and some of my co-founders also trained, in terms of stability and ability to run in steady state, which could be eventually better product market fits to fusion power plants. We are now almost 100 people spread out between Munich, where most of the people are, and Zurich and Oxford, where we have our offices. We just opened a subsidiary in Italy, and probably France will follow suit as well. So we're rapidly expanding across the continent. And we have raised at this point about 180 million between private and public funding, as an announcement was mentioned yesterday. In terms of technology roadmap, we plan to build a net energy stellarator demonstrator by the early 2030s. So this wouldn't be a power plant, but this would be something that should de-risk some of the technologies, particularly on the side of magnets, on the side of the plasma physics for stellarators. But so like it's an intermediate stepping stone towards the first of a kind fusion power plant. And right now we're working on design of the machine and the manufacturing of a coil of a magnet for stellarators using high temperature superconducting magnet technology. In terms of where we are and where we could benefit from more support from the EU, etc. So I think that the most important topic today is how do we secure funding at scale and at speed. So the international competition is clear. I like to make the example of Neo Energy in China that has collected about $1 billion of funding today to basically build what looks very much like Spark, the Spark tokamak by Commonwealth Fusion Systems in the US, but is cheaper because it's built in China. And half of the capital comes directly from the government of Anhui province, which is a region of China where there is a series of magnetic confinement fusion experiments, and about another half comes from basically electric vehicles manufacturing, including Neo, and obviously these are also quite well connected to the government. So this is as if Proxima had received half of €1 billion from the Bavarian government and the other half from BMW and Audi, because the German government told them to give us money. So this is what we are competing with at a global scale. So I think very concretely in the next MFF, this has been mentioned, we need to make a multi-billion euro bet on fusion, which goes beyond ITER. I mean, ITER should be kept funded, and it's a project that should keep going. And I want to make one comment about though how we risk being leapfrogged on that. But whether it's the competitiveness fund, whether it's some other tool, we need to make sure that we can compete with the US and China on the front of funding. Despite us as a European startup having had quite a bit of success in raising private capital, still when you get to the €1 billion scale, there is a gap that can only be matched by public contributions in Europe. At European level, we have the CSA now that's being activated, Consulting and Supportive Action. That's about 100 million. That should start in 2026, 2027. It's great, but we need much more. The German government has created a program that would fund up to 80% of projects of R&D for fusion startups and also the supply chain. And they obtained, there was about 70, 80 million per year between 2024 and 2028. and this was oversubscribed by a factor of 2.5 to 3. So the demand is there if the program is structured well in terms of IP, in terms of co-financing, and for the scale of the EU, we need hundreds of millions per year in additional resources. And yeah, just maybe a quick comment on ITER. So ITER is certainly not the competition for fusion startups. It's complementary. It's a lab where we look more at sort of the commercialization aspect. But there is also a bit of a risk that we need to keep in mind on ITER being leapfrogged. For example, Spark, we should be turning on around 2027. Maybe it's going to be a bit late. We don't know. But around that hallmark, has a good chance of being a burning plasma. I mean, it's designed for Q greater than 2 as the goal, but it has scenarios where it can reach Q of 11. If people remember, for the plasma physics classes, the threshold for burning plasma is Q of 5. So there is a machine that could be the first burning plasma of magnetic confinement. It's not being built in the EU, and ITER scheduled to operate with tritium. I think it's around the end of the 2030s. So we have a 10-year gap there. China is also building the tokamak by Neofusion and BEST, which not sure if they will get to Q of 5, but could certainly get to Q of a few units. And so really we're looking now at the point of we need to shift gears and consider that these challenges will be addressed, and then what are the next challenges in terms of materials, in terms of blankets, and make sure that either program is investing, and Fusion for Energy are also investing in these challenges, which are then critical to the first-of-a-kind fusion power plants.
So, this may be an unfair question, but is the only thing the Chinese are doing better, is it just throwing more money at it? Or are they doing something else that's we could potentially learn from?
So I'm not sure if they're actually spending more money in terms of nominal value. And as you can imagine, €1 or $1 goes much farther in China than it does here, probably a factor of 2 or 3, just because everything from labor, materials, etc., are more expensive. Obviously, the speed at which China is operating, as well as the integration between the public and private sector are, at 100%, right? So. In terms of speed, there is central decision-making, immediate action, immediately placing the order, immediately workers get to work, and all these sort of things. In terms of public and private sector, I mean, to be completely honest, we as a startup in Europe have had increasingly good collaboration with a number of institutions, but generally we're still kept at an arm's length. Sort of like, oh, you want to make money with this, we're a public institution, we need to protect the public interest, blah, blah, blah. I mean, for me, the public interest is to build fusion power plant, but, it's like, months of negotiations on everything, blah, blah, blah. Obviously, in China, is like, there is local governor, local authority, he decides, she sometimes, unfortunately, it's mostly he in China, to do something. The actors get together on the table the next week, stuff is moving, and the collaboration between the public and the private sector is almost complete. So, yeah, I think there is a lot that we can learn. There is still, and this also, I actually have spent most of my career outside of the EU, in the UK, Switzerland, the US, China. I came back to Europe 2 years ago because I still think that we have a very significant advantage technologically. There is some things that others still cannot reproduce, whether it's advanced magnets, whether it's gyrotrons, but every day this gets thinner and thinner, and eventually will be overcome. So unless we act fast, we act at scale, we will lose fusion in a similar fashion that we've lost solar power, that we've lost telecoms, that we've lost other, AI, DeepMind. Everybody now uses ChatGPT, but we could have had ChatGPT made in at least the greater Europe, right? If DeepMind had the capital to develop it rather than being acquired by Google.
Marco, his company is fascinating if you're not familiar with it, but they've produced the largest and most important magnets in the world, used not only by particle physics, but also for many fusion reactors. And In a conversation we had earlier, I had heard you echo some of the sentiments that Lucio just discussed now about, what's the right word, the lack of agility in procurement markets here in Europe, making your own innovation cycles slower. Is that something you could speak to?
Yes, but let me say that the question, and the real issue is a different one, and that it is our fault. I think we should be clear that it's our fault, I mean my fault and the fault of the European fusion community, not being able to raise the voice earlier. I mean, we saw the stone coming down, and we didn't do nothing, or not enough. I mean, the point that the program, some of the programs were late, and that using a sequential approach, doing ITER and then doing something else, demo, was not going to be the right strategy, was probably something that most of us have in his mind. But nobody has a voice to really make this strong. And we should stop blaming something else, somebody else. So sometimes we are raising the blame to the political community, to the DG, to the Fusion for Energy. It's not their fault, it's our fault. It's the technical community working on fusion that was not able to really move up and raise the voice. The question right now that thanks to people like Lucio, Milena, Paolo and others that are shaking the boat, coming out with a startup. This is something that is shaking the environment, but the one with gray hair knew this since here. I mean, the point is that we should have raised this topic before. Now it's fine to have a strategy. It's fine to have a vision. But it's late, but it's our fault. And now we need to go to plan. I mean, it's clear what fusion can bring to the world. It's crystal clear. And it's clear that if we are not acting now, we are losing what we call leadership that is already gone in Europe. So sometimes we keep telling us that we are the master of everything, and we are not anymore. So just make it real. If you're looking to both fusion, now the amount of investment we have seen on fusion are going to China and US. Chinese system is completely different to the European one, as we know. So they are backed up by the states. They are making huge investment. And the reason why they're moving fast is a number of people. Just look into the automotive sector. BYD is becoming one of the leader manufacturers, has 100,000 people in R&D. Toyota, the largest car maker, has 25,000 people. And if you go down to Stellantis or other, it would be a few thousand people. So it's a power of number that it makes it really difficult to compete. And if we are not really united, having a clear strategy, what's going to happen that Europe is really losing the pace. And right now there is no a clear strategy. Some states are moving ahead alone. And the race already started. And we are missing strategy, vision and plan, a real plan. I am not a researcher anymore. I'm now managing a company. My problem is to keep people at work, to have the balance sheet turning not red all the years, having the cash flow to pay stuff and so forth. And I have to transfer the know-how, the issue of fusion, that we cannot live with one program every 20 years. How can I transfer the know-how? How can I keep the investment up and running? So we need a continuous program. So ITER was a marvelous idea, solving both the technological issue and the physical issue of burning plasma at the same time is great. But now we see that it's not enough. We need a parallel program. Working just by sequential is not enough. The others are running ahead. So we need a clear program to tackle all the different technologies. There are plenty of things to have, needs to be addressed, both from the physics side, because still burning plasma is an unknown field, going to whatever you can mention, breeding tritium, first wall material, material able to manage radiation, automotive maintenance. you can name, there are plenty of issues. We should really get people that knows what we are talking about and focalize program on each specific item. So we need to deep dive in the technical side. Otherwise, we are losing once again momentum. So I'm glad that ITER is speeding up, but it's not enough. We need something in parallel to be built. Otherwise, we will lose the race.
So what I think you're saying pretty clearly is someone who has to make difficult decisions about prioritizing your resources towards different potential markets. That could be particle colliders, it could be medical scanners, or it could be magnets for fusion research. Yeah. You're not optimistic about the fusion market?
No, I'm optimistic because it's the only way to go. But I mean, in order to make my company survive, I need to diversify. So I cannot beat on fusion only. Right. I will be dead in a few years, or last year maybe. So this is why we are working, we are building 4 different business units. So we have one business unit on big science, working with the fusion and high energy particle physics. We have a business unit working on medical systems. So we are doing MRI, we are doing ultra field, high field MRI from 0.5 Tesla to 17.6 Tesla. We are working on energy. We are making superconducting cable, superconducting for current limiters. I mean, we are developing, not making, because this is still an investment. And when you are investing, you're spending money. You're burning cash. So you need some entrance. And then we have a business unit making superconducting material. So we develop our MgB2, the magnesium diboride material. That is something in between low temperature, high temperature superconducting that has some peculiar characteristic being very strong material. So it's something you can strand like copper wire. It looks like it's an incolor wire, so it's very strong and reliable. And so we are working in parallel in different directions to survive, but it's not easy.
So when you first started speaking, I may have misunderstood you, but when you first started speaking, I interpreted what you were saying as saying, well, it's about bottom-up coordination of the industry, about the ecosystem, but then towards the end, I think I understood you saying something like, well, we need more of, let's put a fusion reactor on the moon kind of project, and to really marshal public support and political support and make it a big, a mission-driven type of thing. What would it take for you to be more optimistic about investment in the fusion market and really say this is our future?
I mean, what we need within here, we need a clear strategy, a clear vision, but we need a specific plan. So we need money allocated to do what, and this is what we are doing. We need this time frame to get this result, and if not, this will happen. So we need to be much more specific and pragmatic. So right now there are too many words and not enough activity, real facts. So this is a problem that we need to change. And really, I mean, the race is running. Both China, US, and other countries, UK recently announced a 2.5 billion pound investment on fusion. So several countries are moving along, and Europe is at standstill. So still have to decide the vision, the strategy, and to act. So we need to really speed up. So the vision is, let's do it. But let's do it fast, and let's focus on the concrete program to support the development of this industry and support the industry itself. Because if we are not supported by clear development program, we will compete with companies in China or US. They are doing things. I mean, you learn by doing. And if you are building 2 reactors in China, and we are waiting, I mean, we will restart in 10 years from now, and there will be a bid for a magnet in 10 years from now, who is going to win? Mm-hmm. China has just finished making the last 2, or others would made the last one 12 years ago. Okay. So we need to keep going. So we need, if we are not ready to say demo is done in this way, and maybe there are good reasons because we are not able to say how demo should look like. Let's build development programs that are supporting and tackling several engineering and technical issues that are still facing this reaching the final goal. So this is what is, I think, we needed.
Lucio, you had a quick response to that, and then I want to get to Francesca.
Yeah, just very quickly, I think what Marco was talking about aligns very well with sort of like the plans of Proxima and generally of the private sector in Europe. So building some machines in parallel smaller to ITER, and these devices can have different goals. You know, it could be like showing net energy in accelerator, demonstrating the new magnet technology. But as Marco was saying, for example, on magnets, okay, now we have DTT being built in Italy, but other than that, there isn't basically much between now and demo could start ordering magnets in 2040. So as you are a company that have invested a lot of money, you have people with these skills, what are you going to do in the meantime? You're just going to lose that set of skills, which would be a tragedy, especially after having invested so much. And so I think, I mean, individual governments are trying to do this. I think Germany is launching our program. The UK has already their program, the STEP that's quite established. But what are we doing collectively European level? And maybe just also a quick comment on the strategy. So this strategy, European strategy, from my perspective, it's a bit of a ghost because we've been hearing about it for more than 1 year. The private sector, as far as I understand, has not been really consulted, either the supply chain or the startups or the associations. And I think we need a bit more transparency there and of course, a bit more speed and involvement of the different stakeholders.
I'm really interested to hear from Francesca because she represents a voice we don't hear from very often in the fusion world. She works for ENI, which is a very large Italian energy generator and distributor, if I'm correct. They have been really on, you know, some, what's the word, unusually proactive in the fusion space for an incumbent energy company. What is ENI's interest in fusion? Your job is to produce energy today and provide that security in the grid and so forth. Why are you interested in the technology that is so uncertain or you know, so far into the future? How do you see the world?
Thank you for the question. Good afternoon, everyone. And thank you for this invitation. Very happy to be here. Okay, so yes, we are a different actor in the fusion space. We are an energy company. We actually produce oil and gas, but we also have an energy mix. And we are on a decarbonization path. This means we already have in our portfolio renewables, biofuels. Most of them we've developed ourselves. So we are a technology company as well. And so the combination of two means that we keep scanning the world for different options in energy or carbon capture and sequestration and any kind of technology that can get to the market with the objective of using it and delivering energy to the market, because this is what we do. And so when we saw fusion coming up as a new option, well, with new perspectives and with possibly a shorter timeline, we got to know the team now at Commonwealth Fusion Systems proposing on the basis of existing knowledge, like had been done at MIT for years with Alcatos-Imod, but new technology with the new superconductors, we saw the potential, and we believed in that, of having a more compact machine which could be built faster and have the same objectives, because it obviously needs to produce more energy than you consume and everything else. So building on existing physics, or known physics as much as possible, and a new technology. Why did we do that in the US? Because there wasn't an option in Europe. And the private sector was very, very tiny at the moment, in general, in fusion, because there were some examples, mostly in the US, but also in UK. So this was really new. It was disruptive in the idea, and the combination of an energy company and a technology company building up something really not new in concept, because everyone was waiting for high-temperature superconductors and high fields, but it was going to happen. And it is happening, because the magnet was demonstrated in 2021. Spark, that was mentioned, is under construction now, with a lot of components which do come from Europe, apart from the US, and from Italy especially. So there's a combination of skills and technology. This doesn't mean that research that doesn't have to be done. It has. But this is under construction now. And of course, the ambition is to plug, this is Spark at the moment, ARC, to the grid as early as possible in 2030, which is very challenging. Of course, this was disruptive in the fusion community, and I do understand that a lot of people have been very skeptical when I've been talking about this. But things are happening now, and the fusion space has changed very much in between, because of now there are more than 40 startups now coming up in Europe, like Lucio was explaining, and more need to come up. And it was mentioned at the beginning of this panel how important it is to grow a healthy PPP system. But PPP means a lot, and the P meaning private is the supply chain, which needs to be supported with continuity and more than one project at a time, and I agree, but also the prospect of a market, because here what ultimately we are looking for is the market opportunities, which will happen if a combination of things happen: the technology, the cost, the regulatory system, the continuity. So these two things too are very important, and we are addressing them. So we haven't stopped just investing, it's a main investment, and also trying to contribute with learning the technology and contributing with our own skills in oil and gas and big complex projects. We have invested in Italy in the DTT project, which also has a strong relationship with European and Italian supply chain and ITER, and academic work, and a lot of skills and gyrotrons and quenching and stuff like that. We also have an extensive network with the Academy, and are investing in the UK on the heat project for tritium cycle, and they're also engaged in the STEP tender in England. Why are we doing all this? Because if you want to be a true actor in an energy sector, you need to move as much as possible on the different things. And fusion is such a complicated technology and needs a lot of other things that we need to engage as an energy company and on the various levels: technology, regulatory system, industrial perspectives, market perspectives. And I do hope that other utilities will step into the market as well. Some of them have invested, but only financially, in some startups. Now, that's a good point, but it's not enough, because we need end users. We need the market to say, hey, we need fusion, and it needs to perform this, and that. Technology, yes. Magnets, yes. But ultimately, working systems that you can plug in and compete on the energy mix.
So just to clarify, what would it take to get more energy companies to jump in, as you have done?
First of all, keep working on technology, both at R&D and development level, and demonstrate with milestones, clear milestones, achievable and measurable and sensible, and so on. This is the first thing. And this means also supporting with some public money as well, but also supporting the startups and the supply chain to develop their own technology and their own IP and make it profitable. And also make it as sort of solid and meaningful as possible. Not just a dream. I've been to a panel a few weeks ago, and people, it wasn't actually a panel, it was, anyway. And the people are saying, oh, when fusion will come to the market? And some analysts said, if. So we need to drop that if. Because if analysts talk to energy companies, and it's all going to be a very good thing.
Carlos, yeah.
If I could make maybe a little bit provocative and trying to answer in this direction of what is needed and what we should do, and also how the industry could get into it. I think we have to realize one thing. We don't need a better tokamak. I mean, it would be nice. We don't need, actually, what is in the way to obtain energy coming out of electricity coming out of fusion It's not a better tokamak or a better accelerator. It's not even to have better coils. That would be nice, very good. I mean, to optimize and so on. We have to identify, if we really want to have fusion, it's always happened that whenever you are talking and then somebody calls you. So what you need is to identify what are those issues, those technological problems that are in the way to have fusion. You can have the best tokamak in the world right now with a Q of 20. And you still, if you ask the question to the people who came to construct this tokamak and say, okay, can you build now a power plant? They will say no, because we don't have materials, because we don't know how to, we still don't know, we haven't proven that we can get a tritium out of these blankets. We still do not have, we don't know very well how to manage this fuel, this tritium fuel. ITER is going to give answers to many of these questions, but they will not be the final ones. So what I think what we need now in this community that now is not only public but also private is to identify those problems, see how we can attack those problems together. And I think this is one thing that is the key of fusion.
Yes, Jérôme.
Yes, so it's a good point, and it's in the way of what I was saying before, that the problem now is in technologies to go to the power plant, but these issues that you are mentioning are well known and I think well identified by the community, and particularly by Eurofusion, I see Gianfranco, but this is something which is well known, and we know that the step to tackle this technology is huge, and that's the problem. And that cannot be handled by laboratories, not well, for startup maybe, but it's very difficult. What we need is neutrons to get either breeding and to get also neutron material, tolerant materials. So we need neutrons. There is DONES project which has taken years or decades to build it, while we know for a long time that we have to have it as soon as possible to progress on material. So the problem is infrastructures, the technological infrastructure to tackle these issues. And at the laboratory level, it's very difficult to launch them. So we need now to change the scale on that. And also another comment is the fusion community is very small. I mean, compared to the challenge and the energy and the market and everything, if you look at how many people works in fusion in Europe, I mean, scientists, research, or engineer also, it's very small. So if you want to have a strong public-private partnership, we also need to reinforce the public part of fusion. And during this year, it doesn't increase a lot, except in UK. UK has made a strong move, but it's also public size. They bring lots of people in the game, but in Europe, in the present laboratory, it's not the case. So we have also to build the community, global community, and to have new infrastructure dedicated to tackle this issue, which are well known. And there are plans and there are projects for that. So what we need is the funding, the will, and also the people to do that.
Francesca.
Yes, I just wanted to add, I agree with both of you. Just to say, because it was mentioned more than once, Go for Fusion is this ESADE program that we are running in Europe with these objectives. So define what a PPP should look like, what are the other challenges, what are the technology gaps and the priorities, and this is done by a community of research centers, suppliers, ourselves, and it's led by ENEA. And there's a big effort to include all the rest of the community in order to define the technology platform, all the interested actors, in order to listen to all the voices. And this is one step. It's not 100 million, I'm afraid, Lucio. It's only about 1.5 for the moment. But this is a starting point. It's only defining and setting the stage. But I think it's on the right path to understand at European level what is needed. Ultimately, yes, technology gap, they're all taken into consideration, and I'm not saying this is the only instrument, but it's important because it defines and sets the stage for what ultimately needs to be something that you use as an energy source.
So I want to explore a topic which I know it's very controversial, but Massimo mentioned that any public allocations for fusion research are going to compete with defense research, whether we like it or not, right? It's just, yeah. And so the defense narrative has surfaced in Europe in a way it hasn't historically for many years. We saw with the power outage so the public response to it, that people are now understanding the availability of safe and secure energy is a national security concern, not just, a television. And so is there any way, and this is where I'm going to get controversial, is there any way of linking the need for fusion research, fundamental or applied or what have you, to a security narrative, to bring it more under the auspices of defense spending? And the reason I mention this is because, for me, this is just a different variant of the European paradox, which, in policy circles, you always say, well, Europe's great at fundamental research, but the North American and Asian economies are better at appropriating the value from that research. What's wrong? And then the common answer you hear is, well, the defense industry in the United States, of course, provides this tremendous demand to pull and invest in fundamental research. We have semiconductors because of missiles, right? So whether we like it or not, and if you don't have that same type of machine in Europe, then we create other forms of it, societal challenges or what have you. So I'm being controversial, but could we link the need for fusion research to a global security narrative and increase the vibrancy, the economic scale, et cetera, of the PPPs you're talking about?
Well, of course it's a good idea, but then it needs to be declined in a way that it's effective. For instance, if in Europe, if it's fragmented in all the different countries as it is now, with unbalanced prices for electricity, for instance, that just doesn't work. And I'm not the person to say how this could be solved at political level. What we do know is to get the momentum even higher for fusion is that you need a united Europe. We need Europe to be predictable in terms of regulations, of continuity of policy, of the roadmap that needs to be applied in securing funds. It doesn't need to be all the funds all the time at maximum speed, but predictable and with a strategy. And I think this is really very important. Also to attract investments from outside. Because, we can't think of Europe of being isolated in a bubble from the rest of the world. When Marc showed the roadmap for ITER and everything else, and the flags keep growing, I think this is a good thing if it's dealt with in a healthy way.
Lucio, you want to?
Yeah, a couple of comments. I think that we should make that argument as a community as strongly as possible in the next negotiations of MFF, and I am convinced it is true. Energy security is defense in this day and age. It is possible that in a few years' time we're going to have Russian tanks and American tanks facing and German tanks facing each other. But possibly it's more likely that we're going to see increased competition, increased a cutting of energy supplies and these sort of things, and increased hybrid wars, which will tie to quantum, AI, energy supplies, disruptions of supplies around the world in the key sea lines and whatnot. And especially considering the numbers that are connected to defense. We looked at 10 billion invested in Europe over the last 15 years or 10 years for fusion, but the numbers for defense are hundreds of billions invested every year. So even a fraction of that, even if Europe decided the next investments for defense, let's take them, they're 100, we take 10% of that and we put that into technologies. That would be already more than enough to advance fusion and quantum AI, robotics, and other things that will be super important for defense over the next 10 years or so. And then the other point I wanted to make is the fact that right now we're more or less in a sort of scarcity environment where we want to do much more than the resources in terms of people and money allow us to do. But if some of the projects that are currently being built, Spark in the US, BEST in China, the tokamak by Neo Energy, work, and there is like, Spark could make 100, 150 megawatt of fusion power. It's obviously not a power plant yet, but it's something that most investors would look at and see this is a prototype of a fusion power plant. This is like a Kitty Hawk moment. It's like the first flight. And then, those 10 billions that we just looked at could be in 5 years, 30, 40, or 50. And so we need to be prepared with some optimism and lay the groundwork now to that inflection point where actually people will start for real believe that fusion is not just an if, but it's a when, and the resources will be pouring. And by the way, the politicians in Europe, when there is the front page of the New York Times and, Bob Morgard, maybe the COCFS on the cover of Time magazine for, first fusion, blah, 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 Q than 100 megawatt, they will ask us all where we're at and where we're going and what's our plan and why, why the Americans were first and what not and what we're going to do to at least not be third or fourth or fifth after the UK and Japan and whatnot. So we better start working now on best possible answers for the moment where, the ChatGPT moment for fusion.
Okay, for purposes of time, I would like to sort of round out the panel. Before we if you could give us, first of all.
No, just one comment. I mean, it's clear, seems to me that we need to identify what are the key issues to be addressed. This is clear and so forth, and we need a well-defined plan, but we need governance as well. Otherwise, it will be a mess. And I know that Massimo wants Fusion for Energy to be fully focused on delivering components for ITER, but I will leverage their knowledge on all the supply chain in order to not just manage the supply, but manage the development of technology. So this is, in my opinion, something that could help speed up the process.
Okay, so let's do this in extension to that comment, and then I'd like to open up the floor for questions from the audience. One actionable thing that Massimo can take home with him to inform the European fusion strategy. You already said it, but if you just restate it, and then we'll just go down the line.
Okay.
Only one.
One or two.
Okay, so I think for us, the working on the regulatory system is really very important, and getting the priorities in the roadmap. Two, the third one is really getting the PPP to work. We are working on the governance, and that's really very important. So I would like the Commission to be very close to us on this.
Okay. Carlos.
Difficult to say only one, but since you mentioned Europe, I think this idea of going back to a program where somehow all the work in F4E, Eurofusion, this is combined, so to say, under the same governance, I think it would be quite useful to develop a long-term strategy and short-term also strategy. And for that, we will also need industry, I think.
Okay, Jérôme?
Well, difficult question, but I think that we should go for a new facility and to try to build a pilot plant in Europe as it is proposed, or at least a few pilot plants of small scale, maybe not fully competitive in terms of commercialization, but still to bring the TRL higher for all the technological issue we know. So we clearly need other facilities.
Lucio?
I would say two things. First, robust program on technology gaps, materials, neutronics, tritium, with clear deliverables, biased towards hardware development rather than design. We have a bit of a tendency in Europe to sort of like give a few million here and there to different labs, and then after 2 years there is a report on a new type of blanket design, but we haven't actually built anything. We need to do exactly the opposite. Don't write anything on paper, just build. And obviously, some thinking needs to go into it, but like much more biased towards hardware development. And then the other one would be matching support for the private sector, particularly the startups, so that there is at least a level playing field, right? I mean, we don't want to be treated better than the Americans and the Chinese, but we shouldn't be at a disadvantage either.
Very good. Shall we open up for some questions? If if you'd like to stand up and state your name and then your question. Do we have a microphone out there? Yeah.
Hi, yeah. I'll be moderating the Q&A session, and just a word to encourage you to go to Slido, tap that code that you see there, and you can write your questions, and they'll be showing up on the screen. And we can ask a few of the ones that, or also the audience online can ask questions, and we'll be asking them live. You may have the microphone.
Thank you. Thank you. Gianfranco Federici, I represent Eurofusion, and I'm the program manager at the moment. I have a question for Lucio and a question for Marco. Lucio, well, first of all, congratulations to you and to Francesca for getting the money. Okay, I think it's something which has to be recognized, and congratulations, you deserve it. Now, I heard something you mentioned that maybe I didn't capture very well. I'm trying to understand the business case. You said you're planning to have net electricity by early 2030. No, you didn't say that. What I'm trying to understand, how do you get to these dates? Because it looks to me that some of these dates that I hear propagating here are ambitious, aggressive, okay? So you didn't say that. You said a reactor is
would be net energy, like Q greater than 1. Q, like spark, like a stellarator spark.
So, okay, so this is not electricity. So you want to have Q1 with DT plasmas?
Yes.
For how long?
So the performance right now in the device will be able to run in steady state. We're targeting at least 5 confinement times.
Okay, but you don't need it in tritium breeding anything, right?
No.
Okay, so good.
So it's
a
demonstrator.
Because sometimes it's very confusing, because I think we are... The other one was for Marco. Marco and I went together to school. We met 20 years later. We became nuclear engineers. And to explain the story of the pendulums, when we were at the engineering school, there were a plan to build 62 nuclear plants in Italy. Do you remember the famous spoon? And Pandolfi, I mean, Massimo must remember this. He was there. So the pendulum went back, and we had to leave Italy because nuclear power was stopped. We had to go to the US, end up to fusion. Now we're back both in Europe. Now, I agree entirely what you said. Now, just to clarify that I believe the scientific community, you can blame the scientific community, and you need to be blamed. But we know what is missing. That for sure. I think I see a convergence of opinion in all the roundtable, but in all the conferences, we know what is missing. And tomorrow, hopefully, we will be able to explain this to you. You raised the point of governance. That's what is missing. But there is in place right now an attempt in Europe to establish a industrially-led private-public partnership. And frankly, what I miss to hear are statements as clear as the one that you missed. Europe now is trying to understand what industry wants to do. What is really the interest of industry? Is industry really interested to put money in the table and to do something together with the public? Well, that's the question. And it cannot just be money that goes to the magnet, Marco, where you're making your life and your business. It must go somewhere else. But we need to understand how much is industry willing to put on the table and to do what. And this, being involved in this discussion, which Francesca is mentioning, I don't hear that voice. It's very confusing. It looks to me, industry now have to make up a case and say what they want to do to speed up and to bring something under a good governance. Thank you.
I mean, as industry, you know, as Francesca was mentioning before, we are looking for, at the end of the day, having a market. So we are not just developing for the sake of developing something. So we need to have an end point where we start selling what we are developing. Otherwise, this will not fly. So the point is, therefore, that we are willing to invest if there is a market. And we see that there is opportunity, a market there. And this is the reason why, I mean, the company I'm working with is investing in the last 60 years that we are making magnet for this. And if we end up making a balance, we lose a lot of money, because maybe we are making money 1 year, and then for 10 years you are keeping competence and technology up to speed without having nothing to do. So it's a long-term investment that we are already doing. But we are doing because we believe that there will be a market. We believe that fusion will be real. And we want to be part of this when this commercial fusion will come out. So this is the point. We are investing because we believe that there will be a market. Yes. But
Mr. Federici, thank you for breaking the ice with a question from the public. Everybody is encouraged to raise their hand. Maybe I'm going to take the first question that we have on Slido. It concerns F4E, Fusion for Energy. And it says, why should F4E be prevented to take its experience on ITER to other fields of interest for Europe? Maybe it's a question to take home for us at F4E. Maybe the chair of the governing board wishes to address it.
Could you please repeat the question?
Yeah, maybe it's not clear enough and I cannot guess what they meant, but it's why F4E should be prevented to take its experience on ITER to other fields of interest for Europe.
Let me say that it's not prevented at all. Let me mention that in the mission of F4E from the very beginning was certainly the primarily mission to have to develop, to implement ITER through the contributions, the in-kind contributions to the project from Europe, but was also at the very same time to the work on the IFMIF, on the International Fusion Materials Radiation Facility, and the development of DEMO. Of course, the priority, as it was mentioned, it was always, still we haven't finished with the ITER construction, and therefore it was there. But how to, this is, we will have a governing board very soon in July, and we are now dedicating precisely once a year a day to discuss inside the governing board about this strategy to not only to how to get ITER faster and as soon as possible, but also how will be in the long run. I think this capability is a potential, is a tool that we have developed in Europe, and will be very stupid of us if we do not use this huge tool developed by F4E, and the knowledge that it was shown by Marc on the industry, the knowledge of the industry that we have, on the chain of the suppliers and so on, in order to go in particular to issues that have been mentioned, like to have a PPP that could, in principle, accelerate this whole way to fusion.
Thank you. The next question we have, as most voted, comes from Leonardo Biagioni, who is the head of projects at Fusion for Energy, must be around the room. He says, EU is rich in fusion science and technology, but is weak in system integrators able to build end-to-end machines. How to grow integrators to present and near-term projects? Is anybody brave enough? Maybe it's quite a strategic and more big picture.
There is a fast response. We have to build something. We have to make project, and it's by doing projects that we form people. It's not by doing paper. So we have to have new, as I say, a new project in parallel to ITER on fusion, which are of large size and which requires integration and lots of people.
If I may add, yes, have leverage on. Is it working now? Yeah. So projects, and also leveraging on the expertise of people who know how to do big, complex projects. And because system integration is a very important part, and we see that lacking lacking. It has to grow. Yeah.
If I may quickly add, I'm not entirely sure that Europe is that weak on that front. I mean, when you look still globally, I would say Europe is one of the geographies where, you know, a fusion machine of a reasonable size, you know, obviously ITER is a bit of an exception, but, you know, will get built and will likely work. Many other countries struggle with that, including, for example, the United States on the private sector. You know, when you look at the Princeton experiment, or India has had many difficulties and whatnot. But there is a little bit of a revolution that we're also trying to bring up as a private company, as a startup, where we would like to be the integrator. So for the first time, not having a lab or a public organization like ITER F4E that leads the procurement, that leads the design, and then industry that just is supplying, but actually industry leading the construction. Then the government can also be a customer, right? Sort of like or eventually utilities, energy companies will be customers, but like having one private entity that has the money and the trust to lead the entire project, obviously with public and private collaborators and suppliers. I think this could be one of the most important enablers going forward. Professor Dennis White of MIT said that over the last 10 years, he thinks that the two biggest drivers of progress in fusion were the development of high-temperature superconducting magnets and organizational changes where, for example, private companies could be in the driver's seat of entire projects. Not sure if these were the biggest ones, but I think they're definitely like very important ones.
Thank you. Does anybody in the room wish to raise their hands and ask a question? I'm coming over.
Hi, my name is Jack Moore from the Clean Air Task Force. I'm a fusion policy consultant. I wanted to ask a little bit about the idea of the success of private fusion startups being in the public interest in Europe. I think we've seen a focus and a shift towards a focus on the competitiveness strategy released by Mario Draghi late last year. And I think it's pretty clear from our discussion today that fusion hits the three pillars identified as a precondition for growth: the closing of the innovation gap, leveraging decarbonization for growth, and reducing securities by increasing dependencies. So as we're talking about trying to get money into the European fusion program and overcoming public-private divides, I wonder if there's ideas on how we can make a better case on the money coming out of the fusion program and the idea of productivity growth driven through fusion and how we can advocate for that to ensure that the funding's here today to make sure that fusion can drive productivity tomorrow.
So I think, there is multiple aspects of your question. One first is, for example, the innovation dividend and economic multiplier. The UKA, the UK Atomic Energy Agency, as authority actually, has carried out a study which basically says that for every euro, in their case pound, that is invested in fusion technology, about 4 over the following 5 to 10 years, extra pounds get generated in terms of economic growth. This is one of the arguments that you as a professor of business economics would be familiar with. And I think it's true there is much more that we can still do on commercializing fusion technologies beyond fusion. Obviously, ESG has been a prime example on this front, but there is more that we can do. And I think that private startups are probably the entities that are most incentivized to do so, because we have obviously a long runway until we build fusion power plants, and getting early revenue, getting products to market over the next 5 years will be a huge benefit for the companies and whatnot. So I think generally you can consider like a basic industrial R&D benefit, and particularly for fusion you have a few sectors that can be touched. For example, magnets could have better magnets, could have applications in medicine, whether it's MRIs or hadron therapy, in electric engines, large electric engines like 4 megawatt above mostly, which would be like, for example, ships or wind turbines. And you go materials, if we work on 3D printing for some of the advanced steels, obviously this can have applications for lasers. You have optics, have a lot of applications, and whatnot. So I think this is a strong argument, and this is something that we are making to politicians, although we should keep in mind that eventually both investors and politicians are really keen on these sort of like platform applications, but they do find like us getting to fusion as quickly as possible, at large scale as possible, as what we should be striving for.
Thank you. Can I add just one additional comment on this topic? So just giving some example of a follow-up from a fusion research on different area. Sometimes it's not even product we are developing for fusion, but issue we have to tackle for fusion that brings opportunity in other areas. So for example, if you're looking, I'm going back to magnets, I'm sorry, because it's where we're working, so I'm more familiar with these topics. So if you're looking to fusion magnet, they are, you need to carry a huge amount of current to feed them, in the order of 40, 60, depending on the magnet, of course, kiloamps. Now, feeding this amount of current usually is done with a huge bus bar, copper or aluminum bus bar. They are very expensive, they are dissipate a lot of energy and so forth. So looking into how to, let's say, reduce this amount, we come out for idea of having superconducting feeder, superconducting cable, bringing this kind of current without losing too much energy and dissipate energy. Now, this kind of products can have a follow-up in the energy transport business. You need interconnection between grid at the European level, where you have to carry a huge amount of current. Right now this is done going to high voltage and low current, because the conventional conductor can go up to 2,000, 4,000 amps maximum, but you can do a much lower voltage with superconducting cable. So this is a potential follow-up application of what we were thinking to solve a issue on the fusion area.
Thank you. I'm afraid we only have 2 minutes left for the session, so I'm afraid it's too short for another question. We had many, maybe food for thought or food for conversation for the coffee break. We had questions on the role of fusion for energy. We had questions on how startups are addressing technology gaps. We had questions, of course, on the EU strategy and when is it coming. Maybe Mr. Garriba can address it in his closing tomorrow. But other than that, I can just thank you all for the questions. We have a lot on Slido, but please continue the conversation, and I'll let Stavros.
So, Marco, Francesca, Carlos, Jérôme, Lucio, thank you so much for your contributions, your insights. Please.